Good day, students. Welcome to another session for the course Digital Logic Design. My name is Ali Roman, and this session is specifically designed for the students of BCS3A and BCS3D. In this session, we will be covering some more memory concepts. So let us first see what are the contents we will be covering in today's session. So first of all, we will be having the introduction and revision to our previous session, what we have learned in our previous session. Then the most important concept as far as the decoding process of the memory is concerned, we will address that, how a memory decoding is performed here, and we will be designing a static RAM here, and we'll use the concept of memory decoding there. And then we'll see the concept of address multiplexing. What is the need to multiplex the address lines, and what is the importance of this operation and how we're going to do that. So this is the content which we will be covering in today's session. As far as the reference readings and acknowledgements are concerned, we are at chapter number 7 of the book Digital Design with Introduction to Verilog HDL by Maurice Mono. So before discussing the decoding process for the memory, let us first review the contents which we have studied in our previous session. In our previous session, that was basically the introduction to the types of random access memory, and we've seen that random access memories can be categorized into two categories. Either the memory is a static RAM depending upon its architecture or implementation, or the memory is the dynamic RAM. In static RAM, we are using latches in order to store the binary information, whereas in the dynamic RAM we are using the capacitors as a storage element, and whenever we want to store some information to the capacitor, we have to charge that capacitor. So both of the memories have some advantages and disadvantages, and there is a trade-off in order to select which memory we use to opt for our operations and for our implementation. So where the density is important, the cost element is important, that the memory element should be cheaper and with the higher density, and we can compromise on speed and performance, then we'll prefer the dynamic RAM. And where we can prefer on the density and the chip area, and we can have the implementation in such a way that its performance is high, is efficient, the speed element is more as compared to the dynamic RAM, and the cost elements, we can have a compromise on cost elements, and we'll prefer the static RAM here. Then we'll study the concept of the retainment of the data with application of the power, and we've seen that the memories can be distributed or can be classified into two categories. Either the memories are volatile memory or the memory is a non-volatile memory. The volatile memory loses its content when the supply is off, and the non-volatile memory retains its content if we even remove the supply from the circuit. Well, that was from the previous class. Now coming to the decoding process, and we'll see if the memory is being implemented with the help of latches, then how we're gonna decode that, and how the information is being mapped to a cell that is being called as a basic cell, and what is the circuitry that enables us to read or write the data in that particular cell. So cell is a basic structure or the basic unit that can hold a single bit, and we'll call it as a basic cell. So this is basically our basic cell that has got four specific interfaces here. The select line or the select input basically is used to select that particular basic cell for read or write operation. The input in order to write some data into the basic cell, and output line that is used when we are performing the memory read operation. The data that is being stored in the basic cell is being transferred to the output line, and that is further being routed to the processor through the data lines. The read/write control signal that is responsible to decide either we are performing the read bus cycle, or we are performing the write bus cycle, or we are performing the read operation or write operation in simpler words. So these are the four interfaces which each basic cell has. So let us see the internal structure of the basic cell, that how will perform the read and write operations, and how the cell is being selected, and then we're going to decide a 4x4 static RAM. So in order to understand the concept of that memory, we should have the concept of the basic cell. So let us start the internal circuit, that how this basic cell is being organized or structured. So if we see that we are using an SR latch here in order to store information, and we have bunch of some AND gates here and some NOT gates here, and let us see how this circuit will operate. So first of all, let me erase. So in order to select that basic cell, what we have to do is we have to set this select line to 1. If the select line is 1, the input of this AND gate that is being coupled with the output, and these inputs are set to 1. Now this line, read slash write line, will decide either we are performing the read operation or we are performing the write operation. So let us set the value of this line to 1. In that particular case, this input to the AND gate that has been coupled with the output line is 1, and by passing through this inverter, these input lines of these two AND gates are set to 0. So any of the input of the AND gate, if goes to 0, the output is 0, 0 to this SR latch. If we apply 0, 0 to the SR latch that is being implemented with NOR gate, we can refer this figure from figure 5.3 of the book. In that particular case, if both the inputs of S and R are 0, the latch is configured in no change state. That means it retains its information that is being stored in latch. So whatsoever that is being stored here at this output line, that is being applied at this AND gate. If this value is 0, we have an output of 0, and if this value is 1, that means 1 was stored in SR latch, we've got 1 at the output. So basically, if we set read slash write equals to 1, we are performing the read operation. So this line is basically read slash write bar. Now let us see, if we set this particular value to 0, then what would happen? So if we set this value to 0, this circuit has no contribution to the output. We can see that this line goes to 0 and select line was 1. So the output is 0, the default value that is being produced in that particular case. So in that particular case, we are basically writing the data to the latch, and we can see that this 0 is been inverted to 1 here. The select line is already 1, and this line is also 1. Now the input line basically decides what value should move to S and R. So if the input line is 0, S equals to 0, R equals to 1, and if the input line is 1, S equals to 1 and R equals to 0. So here we are basically writing the data to the SR latch, and write operation is performed in this particular case. So I hope so the internal structure and the functionality of the basic cell is clear. In order, the first thing what we have to do is we have to make select line equals to 1. So if select line equals to 1 and read slash write bar equals to 0, we are basically storing the data, or we are performing the write operation to the SR latch or to the basic cell. And if we set this value to 1, we are performing the read operation and data has been out from the basic cell. Now let us start an example of a RAM that is basically a 4x4 static RAM. That means that we've got total number of locations that are 4, and each location can hold a 4-bit data. So this structure is basically a structure of a memory that has 4 specific locations, and each location can hold 4-bit data. If we've got 4 locations, then how many address lines are required to access each location? That is basically 2 raised power 2 static 4 configuration, where 2 are the number of address lines. So we've got a 2-bit address here. For the first location it would be 00, then it's 01, then it's 10, then it's 11. These are basically the addresses that each location contains in that particular scenario. So let us see how we're going to design that structure. One thing which we have to remember is that a single basic cell has the capability to retain a single bit in that static RAM. So in order to store 4 bits on a single location, we have to use 4 basic cells. So in order to store 4 cross 4 bits, then we require 4 cross 4 basic cells in order to implement that memory module. So if we see here, that is basically the detailed diagram of 4 cross 4 RAM. That is basically a static RAM here. Basically this circuit needs a decoding mechanism or mechanism in order to map those address lines on that particular location, that which location we want to select. So basically what we are doing here is we are basically using a 2 cross 4 decoder, that is 2 to 4 line decoder. So according to the address, basically 4 basic cells will be selected at that particular time instant, and these outputs of these decoders, these are basically D0, D1, D2 and D3 at any time instant, depending upon the address, that particular output is high, and basically the output of these decoders are connected to the select lines of the basic cells. So for example, for word 0, these select lines are combined here and are being connected with the decoder output D0. So whenever we apply address 00 here, basically this line goes to 1, all the other line goes to 0. So these are disabled, not selected. In other words, these are not selected, only these 4 cells are selected. So in those 4 cells, either we can perform the read operation or we can perform the write operation. That is totally dependent upon this read slash write line, which is actually read slash write bar. So if this line is 1, basically the content that are being stored in this basic cell, in this basic cell, or this basic cell, or this basic cell, or this basic cell, that is being placed on their respective output lines. that are being carried here. If you can see this structure here, and data is being placed here, and this 4-bit data is out in that particular case. Now if we set this specific line to 0, if we set this line to 0, then in that particular case, if you remember the previous diagram which we have studied about the basic cell, that is been inverted internally by that inverter that has been used in that basic cell, and whatsoever that is being applied on those input lines is being stored in that particular case in that basic cell. So let us see how this will work basically. So during the read operation, the 4 bits are selected of the selected word goes to OR gate to the output terminals, and during the write operation, the data available at the input lines are transferred into the 4 binary cells of the selected word. Let us assume that we've got the address here, that is 10. Assuming that this is the most significant bit and this is the least significant bit of the address line, and we make this memory enable by placing 1 at the enable line. So now this decoder is now enabled. So this word 2 will be selected. If we see that this is 0 0, this is 0 1, this is 1 0, and this is 1 1. These output line corresponds to these codes here. So we've got here 0 at the output of this decoder. We've also got here 0 at the output of this decoder. We've got 1 here at the output of this decoder, output line of this decoder, and we've got 0 here, which clearly means that all those basic cells that are being connected with these lines are not selected, so they are not contributing. They are also not contributing. They are also not contributing. So these cells are basically selected in order to perform the read operation or write operation. So let us assume that previously whatsoever that was stored in those location was 1 0 1 1, and we set this read slash write equals to 1, and since this word line is selected, these 4 basic cells are active here. So whatsoever that has been stored here is been placed here. So we've got 1 0 1 1 at the output. So we have performed the read operation here in that particular case. Now let us assume that we've set this line to 0. Then what would happen? And assuming that the input that has been applied at the input lines are 0 1 1 0. Since read slash write bar equals to 0, which means that we are performing write operation into the basic cell, so whatsoever that is been applied at the input lines here, see here, this one, this one, this one, and this one, that is being stored into the basic cell. So after the execution or performance execution of that operation, or we can say that completion of that cycle, uh, this data 0110 will be returned to these 4 basic cells. So the result will be 0 will be written here, 1 will be written here, 1 will be written here, and 0 will be written here. So in that particular case, we have performed the write operation. So if a memory have 2 raised to power k words of n bits per word, how many address lines that are required? That are basically the k address lines. And what would be the size of the decoder in that particular case? That would be k to 2 raised to power k line decoder. And how many basic cells will be required? That is dependent upon the total number of bits that can be stored in that particular memory. So I hope so the concept of designing a 4x4 RAM, static RAM is now clear. Now let us see the need of address multiplexing. Why there is a multiplexing concept that is being required on the address lines. So more the memory locations are, more the number of address lines are. That means that more number of interfaces are required in order to map that address. But in computer system, we do have some limited number of address lines. So that in order to accommodate all of those locations, what we used to do is we used to use the concept of address multiplexing here. So in order to access all those locations, so definitely that process would require some more time as far as applying a complete address on parallel on all the lines. So if there are limited number of address lines here, we do need the concept of multiplexing here. So where we basically implement that concept, our dynamic RAMs basically typically have 4 times the density of static RAM. So more the capacity, more the number of address lines are required in order to access the particular location in a memory. So if more the number of address lines are required, we must have a dedicated address line in order to access that particular location. But in computer system, we have some limited address bus size, so that in order to access that particular memory location in that particular configuration, we have to multiplex the address. So the cost per bit of the dynamic RAM storage is basically 3 to 4 times less than static RAM, and another factor is low power consumption. That is the reason we use dynamic RAM, and in that particular case, we have to utilize the concept of address multiplexing. So address multiplexing, what will do, basically reduce the number of pins in the IC package, so that we can effectively address each locations in that particular memory, but with have the limited number of pins. So in a two-dimensional array, the address is applied in 2 parts basically at different times, with a row address in order to select the row, and then the column address in order to select the column. So since the same set of pins are used for both part of the address, so we can decrease the size of package significantly. So that is the benefit of using address multiplexing. In order to decrease the size of package, we use this concept of address multiplexing. So that is all for today's class. In today's class, we've learned that how the decoding process for a static RAM cell has been performed. We've studied the basic cell structure and interfaces of the basic cell. Then we've discussed how the read and write operations are performed in and out from the basic cell. Then we've designed a memory that was a 4x4 static RAM, and we've seen the decoding process and the structure and the orientation and the architecture of that memory, how that memory is being organized, and how we'll perform the read and write operation. Then we've seen the requirements of address multiplexing in that particular case, and we've said that in order to decrease our package or in order to reduce the number of pins, we have to apply the address in 2 dimensions, and we have to use the same number of pins, so that same number of interface pins can be used, and those pins can be reduced. So that was all for today's class. I hope so you understand the concept of multiplexing, and as well as you will be able to design a static RAM by using the basic concepts which we have studied in our previous example.